Good morning, students. My name is Samuel Chukwu Emeka. In this video, in this semester, we are studying applied finite mathematics, and in this video, we shall be discussing introductory statistics, part 1. The PowerPoint presentation and also the link to this video shall be on my website, www.samdomforpeace.com. Let's get started. Terms. The terms that we shall talk about in this video are statistics, sample, population, individual, statistic, parameter, statistical process, data, variables. What is statistics? Statistics is a science that deals with the collection, organization, presentation, analysis, and interpretation of data so as to make a conclusion or decision. In some textbooks, they write the presentation as summary. You know, some of it write as summary. So statistics generally involves we collect data, right? We collect some information, we organize that data. We can use frequency table to organize the data. Then we present the data. We present the data. We can use histogram, circlograph or pie charts, bar charts, ogive curve, pictograms, and the rest of them. Then we analyze the data. We make some analysis, right? And we make also some hypothesis testing, and we interpret the data. From the interpretation of data, we now make a conclusion or decision. Basically, we have two types of statistics: descriptive statistics and inferential statistics. Descriptive statistics deals with the organization and presentation of the collected data, right? Then inferential statistics is the science that uses methods that takes the results obtained from a sample, infers it on the population, and measures the reliability of the results. We shall discuss this as we move on. Now, for inferential statistics, we know that usually it is difficult to obtain a data of a population. So what we do is we take some random sample of the population, and from that random sample we analyze it, and we now extend that analysis on the population, and then say how confident we are, or what is the margin of error. So that's measuring the reliability of the results. We shall discuss this as we move on. So why are we learning statistics anyway? The media uses statistics to predict election polls, such as the presidential election, nominate people for awards, and so on. If you read the news on the internet a lot, like I do, you see the results of Gallup polls, or the results of the Fox News polls, or ABC News polls, and if you read it all the way down, you see they talked about the margin of error, right? Now, what these folks do is they don't survey the entire United States population. They do not. They just survey just a random sample of households, and from the results they now infer it on the population. They use inferential statistics a lot, and then they now talk about the margin of error. So They use it to predict election polls. They also use it to nominate people for awards like the Oscars and the rest of them, Grammys, and so on. Now, administrators use statistics to know how their district and schools are performing, and so make decisions as necessary. Okay, they use the results of the data to know, okay, this school is performing good in so-so subject. This school is not performing good, so what do we need to do to make them perform well? Health professionals use statistics to know how different people react to different medicines. Yeah, with time they study the data to see the people with probably different blood groups, how do they react to different ingredient in a medicine or a different chemical in a drug, so that they know probably the ingredient that is causing that reaction and the rest of them. So teachers use statistics to know how to meet the individual student learning needs. Of course, teachers use data a lot. When as a teacher you get the IEP of the student, and you individualize the education plan of the student, and from there, because that's the it contains the data of the student. You know, they track the student data, and you use that data to know what teaching methods, what best teaching strategies to use to make sure that the student understands, to accommodate every student. Okay, and you also use statistics to make informed decisions on who to marry, what car to buy, what school to attend, among others. And the uses go on and on and on. So, of course, you know what I'm talking about. You want to marry, you say, okay, what's the from this family, how have they been behaving? What is the data, or this car, maybe the clutch of this car has been having problems, of this particular brand of car. I'm not going to call any car. But anyway, there are so many uses of statistics, and the list just goes on. So it's important. So what is data? Data is the list of observed values for a variable. We shall talk about this later as we move on. The first point. Then data is the facts used to make a conclusion or decision. So when you get all this data, right, from there you analyze it, you study the data, you analyze it, and then you make a conclusion or decision. Data is also referred to as information. It is collected from a survey, an experiment, a historical record, among others. Data can be numeric, such as age, weight, height. We call them numeric data. Or it can also be non-numeric. That's no numbers. Numeric means numbers. It can be non-numeric, such as color, gender. Data vary. It changes within an individual. It also changes among individuals. This is the bone of contention in studying statistics because of variability. When we talk of variable, variation, variability, it just tells you that it's not constant. It changes all the time. It changes within an individual. Let's say you always eat maybe a bowl of rice every day, right? Maybe yesterday you ate a bowl of rice. Today you ate 2 bowls of rice instead of a bowl of rice, or you ate a half bowl of rice. So you see, it's already changed. It's not, you don't eat the same quantity every day. And also it changes among individuals. If you're a teacher in your classroom, not every student learns at the same pace. You have some students who are taller than the others, You also have students who weigh more, more pounds than others. So it just changes all the time, even among individuals. And understanding the variability of data is very important in statistics. We try to see why that variability of data occurs. Yeah. So collecting data about something involves a study of that thing. Of course, when we want to collect data about something, then we've got to study that thing so that we can collect data about it. And this study could be a measured study or observed study. Okay, it could be measured study or observed study. So this leads us to population, sample, and individual. What is a population? When we want to study an entire group of individuals or thing, an entire group, we call that population. We call that group population. Like, let's say you want to study the entire United States, right? You call that the entire United States the United States population. Let's say you want to study a particular state, maybe the state of Colorado. You call that the entire state, the entire residents of that state becomes the population. Population contains all subjects of interest. Now, sample refers to a subset, which is part of the population or some members of the population that is being studied. It contains some of the subjects of interest. Let's say you now come to the state of Colorado, and maybe you want to know how their eating habits are, right? Probably you get a report sometimes on the state with the fattest people, right? So that it was studied. They did some statistical study to get the list of those states with the fattest people. I know not Colorado is not among them. I'm just using Colorado as an example. Okay, but they go and study that state, the residents of that state, their eating habits. Okay, now it is not possible to get the entire population of Colorado to know their eating habits. It would take so much. It would be very difficult. So what you want to do is to take some random sampling, right? Sample refers to some of those residents. You kind of, from every county, you kind of take some random sample, and you now survey those residents. So sample refers to some members of the population. Then an individual refers to a member of the population that is being studied. So when you just survey one resident of that state of Colorado, then it is that resident is known as an individual. It is that subject of interest. So let's look at example 1. For each of these scenarios, identify the population, the sample, and the individual. A 2012 survey of 100 million Nigerians in Nigeria found that they would prefer the South to succeed from the North. So now, in this case, the population will be the entire Nigerians, right? All the Nigerian people in Nigeria. And then the sample will be 100 million Nigerians in Nigeria, because that was the people that actually participated in the survey. And the individual will be just a Nigerian. Okay? Example 2. A poll contacts 200 ladies aged 19 to 35 and live in the United States and asks whether they use abstinence as a form of birth control. So here, the population will be all the ladies aged 19 to 35 that live in the United States. The sample will be just the 200 ladies that the poll contacted, 200 ladies aged 19 to 35 and live in the United States. And the individual will be just a lady aged 19 to 35 that lives in the United States. Example 3. A farmer randomly sampled 125 plants in his farm on June 27 and weighed the chlorophyll in each plant. So here the population will be all the plants in the farmer's farm on June 27, all the plants. The sample will be 125 plants in his farm on June the 27th, and the individual here will be a plant in his farm on June the 27th. So let's now go back to example 1, the 100 million Nigerians, right, that wants the South to succeed from the North. Now, assuming those 100 million, we know that they are the sample, right? Now, let's say that that out of that 100 million, that 95, you now run a further survey, and you know that 95 million Nigerians out of that 100 million say that they were ready to succeed immediately, right? Maybe you took another survey, and then out of that 100 million, 95 million say they were ready to succeed immediately. So this means 95% of the 100 million, right, are ready for the secession immediately. So in this case, you're just taking the sample and you're getting a result from the sample without anything without touching the population, right? Without anything without touching the population, you're just basing it on the sample. So you're making a conclusion about the sample. You now say that 95% of that 100 million say they were ready to succeed immediately. That 95% was not the population, it was just 95% out of the sample. So this leads us to what we call statistic parameter. So that 95% from the sample is what we call statistic. It is a numerical summary of a sample. Now, assuming you now take that 95%, right, and you now extend it to the population, and you now say, okay, 95% of the Nigerian population wants the South to succeed from the North, right? And this is pretty true. I mean, forget that I'm doing it on video, but it is pretty true. If you run the statistics, I mean, a lot. It may not reach 95%, but it will be close. I mean, it may be close. But anyway, let's continue. So, if you now extend this sample to the population, the Nigerian population, we call this inferential statistics. You're now using 95% out of the 100%, that's 100 million you got from the sample, and you're now making a generalization to the population. You're now extending it to the population that 95% of all Nigerians in Nigeria. So not just the 95% of the 100 million, no, but 95% of all Nigerians in Nigeria said they were ready to succeed immediately. So that means you're getting information from the sample and you're extending it on the population. Then that 95% becomes the parameter, right? And this is what we call inferential statistics. When you now extend that when you now generalize it to the population. So the 95% now becomes the parameter. A parameter is a numerical summary of a population. So let's look at some examples. Example 4. For each of these scenarios, determine whether the underlying value is a statistic or parameter. A sample of London residents were surveyed, and it was found that 85% had a bachelor's degree or higher. So in this case, because it's a sample of London residents, it was not the entire population of London residents. Because it was a sample, the 85% is a statistic. Example 5. 26 of the 50 states in the United States voted for Barack Obama in the 2012 presidential elections. So in this case, we are looking at the the bold letters that are underlined, those are the ones that we need to tell whether they are statistic or parameter. In this case, we say that 50 states is a parameter because it is the entire United States, is the numerical summary of the population of the states in the United States, while 26 is a statistic because it's a numerical summary of the sample of the states in the United States. Example 6. A recent study from Harvard University researchers found that of 93,600 women aged between 25 and 42, 3 or more servings of berries per week may slash the risk of a heart attack by 33%. And the source is from the Journal of American Heart Association. So in this case, we look at Harvard University just surveyed 93,600 women. They didn't say from which country, but it probably is from all over the world. So, but they are aged between 25 and 42. So this is actually a sample. And because it's a sample, the 33% is a statistic. Statistical process. Statistics follows, we call it a science because it follows the scientific process. Now let's look at the basic steps of a statistical process. The first step is to identify the research objective. What do you want to find? Okay, what is your research about? What problem do you want to solve? So if you know that, then what are the necessary questions to ask to solve that problem? And after that, you now say, okay, what is my population of study? You have to identify your population of the study. Then the next step is to collect the data needed to answer the questions. We use the appropriate data collection techniques. Usually to collect information about an entire population is difficult. So what we want to do is to get a sample of that population. But now when you're getting a sample of the population, you have to consider, okay, how random will be the sample. You don't just go and get a sample from one area. You have to randomize the sample, and also how large is the sample size. We usually consider a large sample size. Then the next thing you want to do is to describe the data, obtain a descriptive statistics of your sample data, organize your data, present or summarize your data properly. And then you now perform inference. You now apply appropriate techniques to infer or extend the results of your sample data to the population of your study. You now make an inference, you extend it to the population, and then you now report a level of reliability of the results. How confident are you in your result? Okay, are you 90% confident? Are you 95% confident? And then what is the margin of error? As I said earlier, if you look at the polls they usually take, like the Gallup polls, Fox News polls, ABC polls. If you look, if you read it, then at the very end, it tells you, okay, that this poll is within 3.5% margin of error. Okay, it tells you the margin of error, which is very important that they report the margin of error. It just tells you, it's just part of saying the reliability of the result. So once a research objective is stated and the population is identified, the researcher must create a list of information of the individuals of the population. So when you have your research objective, what you want to find out about, and you identify the population of your study, you now create a list of the individuals of the population, right? And this leads us to what we call variables. A variable is a characteristic of the individual, of the population being studied. So, of course, your population, when you look at the individual individuals of a population, the characteristic of the individual is what we call variables. And the name implies it always varies. Okay. Now, variables can be classified as qualitative or categorical variables, and also quantitative variables. Then we can also further classify quantitative variables as discrete variables and continuous variables. So let's look at them now. Quality, from the term qualitative variables. You see, quality is not numbers, it's not numerical, right? It expresses qualitative attributes of the individuals of a population. It is not measurable. Now, it is not usually a numeric value, not usually. Yeah. In rare instances, you might have a numeric value, something like zip code, but usually it is about quality. Okay, it is not measurable. Examples are gender, like male, female, favorite color. Oh, my favorite color is red. Then green, blue, and the rest of them. Religion, Christianity, Islam, Judaism, street names, then zip codes, something like zip codes. You know, with the United States zip code, I know some other countries may not have zip codes that are entirely numeric, but the United States zip code, which a 5-digit zip code or 9-digit zip code that is numeric, you know, it's kind of confusing here, because you might say, okay, why don't we call it quantitative variables? It's still qualitative variables because you can't measure it. Yeah, so that's why we classify it as that. It is not measurable at all. Now, with the quantitative variables, quantity. Now, when you talk of quantity, you're talking about numeric value, right? Numbers, something you can count, something you can measure, right? Quantitative variables. So it is always measurable and it always has a numeric value. Examples include age of students, area of a room, volume of a box, temperature, weight, height, shoe size, and so on and so forth. Now, let us now look at the types of quantitative variables. And we see that they can be discrete variables and continuous variables. Excuse me. Okay, discrete variables. These are quantitative variables that has a finite or countable number of possible values. Oh, excuse me. Now, something with discrete variables, if you can count it, it's discrete. If you can measure it, it's continuous. If you can count it, it is discrete. Okay. Now remember, I said that quantity you can either count it or you can measure it. Now, when you count it, it is discrete. When you measure it, it is continuous. Okay. So, for example, number of prime numbers obtained after tossing 2 dice one time. Number of kings in a deck of cards. Number of queens in a deck of cards. Number of United States senators, and so on and so forth. You count, right? You don't measure. They are discrete variables. Continuous variables. Continuous variables are quantitative variables that has an infinite or uncountable number of possible values. In this case, you measure it, right? Example, the time it takes for the sequester to take effect, right? We knew that the sequester in the United States started on a Friday, okay? So what time does it take to now see the effect? You know, due to the ineffective and inactive senators and congressmen who are always at loggerheads. That's by the way, right? Okay. Then the distance between Nigeria and the United States, we measure it. We measure time. We measure distance. We don't count it. So these are discrete variables. Now, on the sidelines, we also have what we call dependent and independent variables. Now, these are kind of not really types of variables, but when we do experiments, we take note of these dependent and independent variables. And not just in statistics, in mathematics generally, you've seen y is a function of x, written as y equal to f of x. Okay, dependent variables are also known as the response variables. They are variables you can predict. They are the outcome of a study, and they are the y value function. They are dependent. And the independent variables are also known as explanatory or predictor variables. They are variables that explain the response variables. They are the x value function. And in algebra and calculus, we know that y is a function of x. Now, let me talk a little about this, okay? If you, like, let's say now that, let's say that cheeseburgers, I'm probably not pronouncing the word cheese right. Okay, but burgers, cheeseburgers, right? Let's call it B. And let's call the weight W. You know that when you eat burgers, you gain pounds, you gain weight. Okay, so we now say, okay, that weight is a function of burgers. So we just say W is F parenthesis B, and we close parenthesis. Now, that W is dependent on how many burgers you eat. You eat more burgers, you gain more weight. You eat less burgers, you still gain weight, but not as much. Okay, so, but you see that the burgers, the cheeseburgers, are the independent variables because they are alone, right? They didn't ask for your trouble. You just went to McDonald's and you bought it. Okay, so your weight depends on it. The more you eat it, the more weight you gain. So that is the way you see dependent and independent variables. Okay, the x and the y. Well, the y and the x. Y is the dependent, x is independent. Now, data and variables. The type of variable dictates the methods that can be used to analyze the data. Qualitative data are observations that correspond to qualitative variable. Quantitative data are observations that correspond to a quantitative variable. Discrete data are observations that correspond to a discrete variable. And continuous data are observations that correspond to a continuous variable. Now, let's look at the level of measurement of a variable. Assuming we do not want to classify variables as qualitative, qualitative, or quantitative, or discrete, or continuous. Let's say we don't want to classify variables that way, right? Another way we can classify a variable is by assigning a level of measurement to the variable. The level of measurement, we mean it determines the types of descriptive and inferential statistics that may be applied to a variable. And those levels of measurement are nominal, ordinal, interval, and ratio variables. Nominal level. A variable is at the nominal level of measurement if the variable name, label, categorize, or code. Oh, that should be code, please. I'm sorry. Wrote it as coded. Or code. But the main thing is that the order of ranking is irrelevant. It's not relevant at all. So when you see a variable that names, labels, categorize, or codes, okay, whereby the order of ranking is irrelevant, that variable is at the nominal level of measurement. Example, we have the race, African American, European American, nationality, Nigeria, United States, religion, Christianity, Islam, Hindu, Judaism, marital status, single, married, and so on and so forth. Ordinal level. A variable is at the ordinal level when it has the properties of the nominal level, but in which the order of ranking is relevant. In this level, the order of ranking is important. Okay, like the Likert scales, we call it Likert scales. When you have the strongly agree, neutral, disagree, strongly disagree. Now, these are the scales that your actually, in this semester, you will be required to complete a formative survey at the beginning of the semester and a summative survey, formative and summative survey. And they use Likert scales in those surveys, formative evaluation and a summative evaluation. Formative you complete at the beginning of the semester, summative you complete at the end of the semester. So they use Likert scales there. Now grades, of course, I know you all want good grades. Who doesn't want good grades? A, B, C, D, F, right? In Nigeria, we also have E there. Yeah. Rankings: first, second, third, fourth, 5 stars, 4 stars. Well, you go, you see 5 movie star, right? They gave this movie 5 stars, or they gave this hotel 4-star hotel. Okay, when we talk about those rankings, these are the ordinal level of measurement. Levels: high, medium, low, thumbs up, thumbs down, and so on and so forth. Interval level: a variable is at the interval level of measurement if it has the properties of the ordinal level of measurement, but in which the difference between the values of the variable is measurable and meaningful. Now, when we look at the ordinal level of measurement, we see that the difference, like, what will you say is the difference between a 5 movie star and a 4 movie star? Or maybe a 5-star hotel and a 4-star hotel? Or maybe the difference between grade A and grade B? I mean, the difference doesn't make meaning. Like, there's no numerical difference, right? We can't perform arithmetic operations of addition and subtraction on them. Like, you can't say grade A plus grade B, right? Or you can't say 5-star movie minus 4-star movie. Okay, you can't say it. So there is no starting point. I'm sorry. In that ordinal level, the difference is not meaningful at all. So, but in the interval level, the difference is measurable and it's meaningful. You can perform arithmetic operations of addition and subtraction on these variables, but the problem is that there is no zero starting point. It doesn't start from 0, and because it doesn't start from 0 at this level, interval level, the ratios are meaningless. Now let's look at example calendar dates. Please, have you ever heard of 0 year? I mean, we know about probably 56 or 560 BC, before Christ, or 560 AD, right? And Anno Domino, I think, yeah, after the death of Christ, or maybe 1920, 1970, 2014, 2013, 2014, but you don't see 0 year, right? So because of that, the ratios doesn't make meaning. Likewise, the Celsius temperature, Fahrenheit temperature. Okay, do you think the lowest Fahrenheit temperature is 0 degree Fahrenheit? Well, if you go to North Dakota, sometimes it's -5 degree Fahrenheit. Sometimes it's -10 degree Fahrenheit. In Canada, sometimes it's -20 degree Fahrenheit. So there is no 0 starting point. So the ratios are meaningless here. But the difference is still meaningful, right? The difference you can perform, of course, you can say 5 degrees Celsius plus 75 degrees Celsius to give you 80 degrees Celsius. Okay, you can perform arithmetic operations of addition and subtraction on them. The only thing is that the ratios are meaningless. And then the ratio level. A variable is at the ratio level of measurement if it has the properties of the interval level of measurement, but in which there is a 0 starting point, and the ratios of data values are meaningful. Here, we have a 0 starting point, and the ratio are meaningful. You can perform arithmetic operations of multiplication and division on these values. Examples: weights of people, Kelvin temperatures. Of course, we have 0 Kelvin. We don't have -5 Kelvin, no. So we have 0 pounds. Okay, like some food you eat doesn't contain any calories at all. Zero calories. Okay, then time between the deposit of a check and the clearance of the check, right? Probably time you say, like, let's say even time to start a race. On your marks, get set, go. when they say on your marks, it's at 0 seconds. Then get set and then go, and then they start counting the seconds. So you see, it has a 0 starting point. Volume of water used by a household, and so on and so forth. Okay, example 7. Identify the individuals, variables, and their corresponding data, and the type of variable in the data below, in the table below. So we have participants, weight in pounds, type, and then price in dollars. So we want to find the individuals, then we want to find the variables, then we want to find the variables and their data, and then we want to say what type of variable they are. Okay, now the individuals here are the participants: participant A, participant B, participant C, participant D, and participant E. They are the individuals. The variables are the weight in pound, type, and then the price in dollars. Then the variables and their corresponding data. We have weight in pound, 170, 250, 120, 100, 300 pounds. The type: athletic, muscular, athletic, skinny, obese. Then price in dollar: 20, 50, 15, 10, 95. The variables and the types of variables are the weight. Of course, if you look at weight is a continuous variable. You can measure it. It's continuous variable. Type is a qualitative variable, and the price is discrete variable. You count it. You can measure price, you count it. Weight, you measure it. It's continuous. Example 8. A study looked at the impact of berries consumption in women. Of the 93,600 women aged 25 to 42 involved in the study, it found that 3 or more servings of berries per week may slash the risk of a heart attack by 33%. Assume the study was done with a margin of error of 5% and a 95% confidence level. What is the A? What is the research objective? B. Identify the population. C. Identify the sample. D. List the descriptive statistics. E. What can be inferred from the study? So we look at this now. The research objective is to determine the effect of berries consumption in reducing the risk of heart attack in women. So you came up with a question, okay? Let me see the effect of berries on women. Women who consume berries every week. Let me see the effect of berries on the risk of them having a heart attack. And you choose women aged 25 years to 42 years. So the research objective is to determine the effect of berries consumption in reducing the risk of heart attack in women aged 25 to 42 years. The population is all women, that is aged 25 to 42. Now, they didn't tell us a particular country, so we assume it's countries all over the world. So any woman aged 25 to 42 is the population. And it will be very, very difficult. It will even be meaningless to get a data based on that population. So we now use a sample. And the sample is just 93,600 women aged 25 to 42. Now, what is the descriptive statistics? The result of the result of the research is that it found that 3 or more servings of berries per week may slash the risk of a heart attack by 33%. What can you infer? What is the conclusion of the study? You can now extend this on the population by saying that the study is 95% certain that 3 or more servings of berries per week may slash the risk of a heart attack between 28% and 38%. Now, 95% certain is because of the 95% confidence level. Then it has a 5% margin of error. So let's say 33% minus 5% gives 28%. 33% plus 5% gives 38%. For this class, we have, as we move on, at least this will get you started this week. It will get you started this week. So just know I'm there for you. If you have any questions, you can always contact me. There are some financial calculators that are on my website under finite math and discrete math. Some of them are really useful that will help you a lot in this course, so that it will kind of make some calculations easier, and we shall be talking about those as we move on. All right, thank you so much for coming to this. Thank you so much for listening. Did I say coming? Thank you so much for listening to this presentation, and you have a great day.